This is all about Erik Erikson's 8 stages of psychosocial development. So here's what we've got on tap. We'll start by seeing how Erikson kind of shook things up. Then we'll get into the real heart of his theory, this idea of a psychosocial crisis. After that, it's a step-by-step journey through all the stages, from when we're little kids all the way to adulthood. And we'll wrap up by looking at how we reflect on a life well lived. Ready? Let's jump in. Okay, so to really get where Erikson was coming from, you've got to start with Freud. I mean, Erikson didn't just throw Freud's ideas out the window, he built on them, but he also took a hard left turn. See, Freud was all about sexual drives being the main motivator. Erikson, he said, hold on, what about our need to connect, our social lives? He argued that was the real driving force. And here's the kicker. Freud was pretty focused on just the first 5 years of life. Erikson came along and said, nope, we're developing our entire lives. That was a huge, game-changing idea back then. So what's the engine that powers all this development? Well, Erikson called it the psychosocial crisis. And I know what you're thinking. Crisis sounds bad, right? Like a total disaster. But that's not what he meant at all. For Erikson, a crisis is more like a turning point, a fork in the road. It's a moment where, yeah, you're a bit more vulnerable, but you also have this incredible potential to grow. Every single stage we're about to talk about is all about navigating one of these crucial turning points. And here it is, the whole map of the journey laid out. Erikson's framework gives us these 8 distinct stages, and each one has its own central conflict to resolve. It starts with trust versus mistrust, right when we're born, and it takes us all the way to integrity versus despair in our final years. So let's dive in and start at the beginning, stage 1. All right, our journey starts right at the beginning. Stage 1, trust versus mistrust. Think about it. As a baby, you are completely and totally dependent on your caregivers. That's the challenge. So if your needs are met, if you're fed, comforted, and cared for consistently, you learn to trust. You start to believe the world is a pretty good and safe place. But if that care is spotty or unreliable, well, that's where mistrust starts to creep in. And this is so fundamental because that initial outlook, it pretty much becomes the filter through which you see every relationship for the rest of your life. Okay, moving on. From about age 1 to 3, we hit the toddler years, and that brings us to the next big turning point, autonomy versus shame and doubt. Ah, yes, this is the I can do it myself stage. We've all seen it, right? It's all about a toddler discovering their own will and trying to be independent. Now, if parents and caregivers can create a safe space for them to explore and, make a few messes, the child develops a healthy sense of autonomy. But on the flip side, if they're constantly punished or criticized too harshly for trying, they can start to feel a deep sense of shame and doubt their own abilities. And that feeling, that can stick around for a long, long time. All right, so as kids head into the preschool years, their world just explodes. It gets so much bigger, which leads us right into stage 3, initiative versus guilt. This is when kids start making up their own games, planning little adventures, and really engaging with other kids. They're taking initiative. And when that's encouraged, they start to develop a real sense of purpose. They feel confident, like they can lead and make things happen. But if their big ideas are always shot down, or if they're made to feel like they're just getting in the way, a feeling of guilt can set in. They might become more of a follower, too scared to ever speak up and share their own ideas. Now, when kids hit elementary school, the whole game changes. The focus shifts in a big way, and we enter stage 4, industry versus inferiority. So the new arena is the school, the classroom, the playground, you name it. The main challenge, it's all about mastering stuff, whether it's multiplication tables or just learning how to make friends. And when kids succeed, when they see their hard work pay off in a good grade or a new friendship, they build what Erikson called industry. It's a sense of competence. But if they're constantly feeling behind, if they just can't seem to keep up with their peers, that can lead to a really powerful sense of inferiority. Okay, now we're getting to the big one. This is probably Erikson's most famous stage, the one that really defines those teenage years, identity versus identity confusion. The central question of this stage is massive. Who am I? What am I all about? And where the heck am I going? It's a time for trying on different hats, exploring different beliefs, different friend groups, you name it, all in the service of figuring out who you really are. If you come out the other side with a good sense of that, you've got a stable identity. But if you don't get that chance to explore, or if you get lost along the way, you can end up with what Erikson called identity confusion, just kind of drifting without a real anchor. So, once you've got a pretty good handle on who you are, the journey continues. You move into early adulthood and face the next big challenge: intimacy versus isolation. And this is really important. Erikson believed you can't really be intimate with someone else until you know who you are. A solid sense of self is the foundation. So the main task here is to build those deep, meaningful relationships, both with partners and friends. When you succeed, you find real intimacy. But if you're afraid to let people in, or if that identity is still shaky, the alternative can be a really painful sense of isolation. And the journey keeps going. As we move into middle adulthood, our perspective widens and our focus shifts yet again. This brings us to stage 7, generativity versus stagnation. At this point, it's less about me and more about we and the future. Generativity is just a fancy word for making your mark on the world, for creating or nurturing things that are going to outlast you. This could be raising kids for sure, but it could also be mentoring younger people at work, getting involved in your community, or contributing to a cause you believe in. It's about legacy. The flip side of that is stagnation, that feeling of being stuck, of having done nothing really meaningful to help the next generation. And that brings us to the final chapter of this incredible journey. As we get older, it's only natural to look back over our shoulder at the life we've lived. And this quote really, really nails the feeling of that moment. This is stage 8, the final stage, which happens in late adulthood: integrity versus despair. So the challenge now is to look back. It's a life review. And if you look back and see a life that had meaning, a life well spent, even with its ups and downs, if you can accept the whole thing, you achieve a sense of integrity, a kind of peace or wisdom. But if that look back is filled with regret, with a lot of should-haves and what-ifs, Erikson said the result is despair. You've probably heard this a million times in psychology class: nature versus nurture. Is it our genes or our environment? Are we just the sum of our DNA, or are we completely sculpted by everything we experience? Well, it turns out looking at it that way is a massive oversimplification. But what if the answer is way more interesting than just one or the other? This is where psychologist Urie Bronfenbrenner comes in, with this simple but honestly revolutionary idea. He argued that if you really want to understand a person, you absolutely have to understand the world they live in. So let's really get into the heart of this perspective. Bronfenbrenner's ecological systems theory basically says that our development isn't something that just happens to us. No, it's the result of this constant dynamic give and take between us and all the different layers of our environment. The whole focus shifts from what happens to us to what's happening with and around us. Okay, so this whole theory rests on a few key ideas. First, it fully accepts that it's biology and environment working together. It sees the environment not as one big thing, but as a series of nested structures, kind of like those Russian nesting dolls. And these systems are always interacting. A change in one layer is going to send ripples through all the others. And maybe most importantly, this isn't just a childhood thing. It's a lifelong process that's always shaped by time. So what are these nested structures? This is where the theory really comes to life. Bronfenbrenner laid out 5 distinct but totally interconnected environmental systems that shape who we are. Let's break them down one by one. We'll start at the very center with the microsystem. This is your immediate world. It's the setting where your day-to-day life actually happens. And it has the most direct and powerful influence on you, because this is where you have all your personal face-to-face interactions. So think about your family, your closest friends, your school, or even your workplace. Those are all your microsystems. A really supportive teacher, for example, can spark a love of learning that stays with you forever. On the flip side, a really stressful home life can seriously affect a child's sense of security. This is where the real nitty-gritty of development happens. Okay, moving one layer out, we get to the mesosystem. Now, this isn't really a new place. It's more like the web of connections between all of your different microsystems. Think of it like the connective tissue that links together all the different parts of your daily life. And here's the key. It's all about the quality of those connections. For instance, when parents and teachers are on the same page and communicating well, a student's grades and social life almost always get better. A strong mesosystem creates consistency and support. But a weak or broken one, that can create a lot of friction and challenges for someone's development. Now, this third layer, the exosystem, is where things get really fascinating. It's made up of social settings that you're not even directly a part of, but they still have a big, indirect impact on your life and your development. A classic example for a kid is their parents' job. The child never actually goes to the office, right? But if their parent gets a promotion or a pay cut or even loses their job, you can bet the changes in family stress, time, and money are going to ripple down and totally affect that child's world. And now we get to the biggest, outermost layer of them all, the macro system. You can think of this as the cultural blueprint for your entire society. It's the whole collection of ideologies, social norms, laws, and values that basically sets the stage for everyone living in it. This is the big picture stuff. We're talking political systems, economic philosophies, cultural attitudes about gender or family, the works. For example, a country's education policies and how much it funds its schools, that's the macro system, directly impacts the quality of the school, the microsystem, that every child experiences. It really does set the blueprint for everything else. But there's one more piece to this puzzle, and it's a big one. It cuts across all the other layers. It's the chronosystem. This is all about the influence of time, both the timing of events in your own life, like your parents getting divorced, and the larger historical period you happen to be living in. So a personal event like a divorce can completely reshape a family's microsystem, but so can a huge historical event. Think about it. Growing up in the digital age with smartphones in your pocket from day one is a fundamentally different experience that shapes your social development compared to growing up just a few decades ago. Time changes everything. Okay, so now we've got these 5 systems, right? But the real genius here isn't just knowing what they are. It's seeing how they all interact. This isn't some static model. It's a living, breathing, dynamic process. And one of the most important ideas here is that this is a two-way street. It's not just that the environment shapes a person, the person also shapes their environment. Look at this example. An anxious child might act really cautiously. This could lead their parents to become overprotective. But that overprotection can actually reinforce the child's cautious behavior, which might make their anxiety even worse over time. You see? It's a feedback loop. Later on, Bronfenbrenner actually formalized this whole dynamic thing into his process-person-context-time model, or PPCT for short. He said that the real engines of development are what he called proximal processes. These are those regular, ongoing, complex interactions, like a parent and child reading together every single night. It's through these consistent activities that our genetic potential really comes to life within our specific world. So a theory is great and all, but what's it good for in the real world? Let's talk about how this framework is actually used, and we should also look at some of the fair criticisms it's received. The number one strength of this theory, it's just so holistic. It moves past easy answers and gives us this rich, complex map for understanding why people are the way they are. And that is exactly why it's so incredibly valuable in fields like education, social work, and therapy. It forces practitioners to see the whole person in their whole world. But, no theory is perfect. One critique is that, unlike, say, Piaget, it doesn't give you a neat sequence of developmental stages. And because it's so complex with all these interacting layers, it's really, really hard to test in a controlled lab experiment. So it ends up working more as a fantastic way to understand context, rather than a model that can predict specific outcomes. Okay, let's bring this all home. Because honestly, the best way to really get this theory is to apply it to yourself. So let's quickly map these ideas onto our own lives. So here's a quick recap to tie it all together. You've got the microsystem, your direct world, the mesosystem, how those worlds connect, the exosystem, the indirect influences, the huge macrosystem, your culture and society, and finally, the chronosystem, the powerful dimension of time that flows through everything. And really, if you remember one thing from all this, it should be this sentence. It perfectly sums up Bronfenbrenner's entire game-changing idea. We aren't developed in some kind of vacuum. We are the product of this complex, amazing, and constantly changing dance between who we are and the world that surrounds us. Piaget's entire life's work was really driven by one huge, fascinating question. How on earth do we get from a baby's world, which is all about immediate feelings, sensations, and actions, to the incredibly complex internal universe of an adult filled with logic, morality, and long-term plans? It's a massive puzzle, and he dedicated his life to trying to solve it. And his answer? Well, it was absolutely revolutionary for its time. See, before Piaget, the common view was that kids were basically just empty jars passively waiting for adults to pour knowledge into them. But Piaget came along and said, no, that's all wrong. He argued that children are dynamic, that they're constantly experimenting with the world and building their own mental models of how reality works. They're like little scientists in the lab of life. And this one idea, that learning is active, not passive, completely changed the game for education. So if kids are these little builders, what are their tools? What are they working with? Piaget identified a few core mechanisms that are absolutely essential for constructing knowledge. Let's take a look at the actual machinery behind how the mind grows. Okay, so the most basic building block of all is something Piaget called a schema. The easiest way to think about a schema is as a mental filing cabinet. It's a category, or maybe a script, that we use to organize all the information coming in. It's the mental framework that helps us make sense of our experiences. So for a really young child, the dog schema is probably pretty simple, right? If they see something that has 4 legs, it's covered in fur, and it barks, boom, it fits perfectly into their dog file. It's a very basic, but really functional pattern for identifying a specific type of animal. But how do these schemas get more complex? Well, Piaget described this elegant process of adaptation that really works in 2 key ways. First, you have assimilation. This is when we try to cram new information into our existing mental files. But what happens when something new just doesn't fit? That's when accommodation kicks in. That's the process of either changing our existing mental files or creating entirely new ones. And the engine that drives this whole back and forth process is what he called equilibration. It's our mind's natural push towards wanting things to make sense. Let's see this in action. It makes it so much clearer. A child sees a cow for the very first time. It's got 4 legs and it's got fur, so their brain tries to assimilate it into their existing dog schema. They shout, "Look, big dog!" But then an adult gently corrects them. "No, honey, that's a cow." And this creates a moment of, well, cognitive imbalance. It doesn't quite compute. To restore that balance, the child has to accommodate. They build a brand new mental file, a cow schema, that's separate from their dog one. And right there, in that little moment, cognitive growth has just happened. Now, Piaget believed this whole process of construction doesn't just happen randomly. He proposed that it unfolds in a sequence of 4 distinct, universal stages. And each stage isn't just about knowing more. It's about a completely different way of thinking. It's kind of like upgrading the entire operating system of your mind. It all starts with the sensory motor stage. In this phase, infants understand the world entirely through what they can see, hear, touch, taste, and do. It's a world of pure, immediate sensation and action. And the single biggest achievement of this whole period is developing object permanence, that critical understanding that things continue to exist even when you can't perceive them. You know, for a very young infant, out of sight is literally out of mind. If you hide their favorite toy under a blanket, as far as they're concerned, it has ceased to exist. The massive aha moment is that breakthrough, that incredible discovery that even when they can't see the toy or your face during a game of peekaboo, it's still there. This is the very first step toward having mental representations of the world. And that ability for mental representation just explodes in the preoperational stage. The child's mind is suddenly buzzing with symbolic thought. A cardboard box becomes a spaceship, a stick becomes a magic wand, and their language skills develop at an incredible pace. But their thinking is still very intuitive. It's not governed by logic yet. And it's marked by this key limitation: egocentrism. They find it incredibly difficult to see the world from anyone else's point of view. And here's the classic experiment that shows this limitation so perfectly: the conservation task. If you pour the same amount of water from a short, wide glass into a tall, thin one, a preoperational child will almost always say the tall glass has more. They get fooled by appearances. They can only focus on one dimension, in this case the height of the water, and they can't mentally reverse the action to realize the quantity is the same. Their perception totally overrides their logic. The big breakthrough finally comes in the concrete operational stage. Now, the child's thinking becomes much more organized and logical. But, and this is a big but, it's still tied to the physical, concrete world. They can perform logical operations, but only on things they can physically see and touch. This is when they finally master concepts like conservation. So, the child in this stage can now mentally pour that water back and forth between the 2 glasses. They understand that a change in one dimension, like the height, is compensated for by a change in another, like the width. They can finally apply logical rules, but again, only to the concrete world right in front of them. And finally, we arrive at the formal operational stage. This is the last major upgrade.
The mind is basically unshackled from the concrete world and can now soar into the realm of the abstract. Thinking becomes systematic, it becomes hypothetical, and we can reason about things that aren't even physically present.
This is the stage that opens the door for higher-level math, like algebra, for deep philosophical debates, for true scientific reasoning. We can think about all the possibilities, not just reality. We can formulate a hypothesis and then deduce the logical conclusions. And we can finally grapple with huge abstract concepts like justice, infinity, or what we want our lives to look like 10 years from now.
So there you have it. That's the entire journey mapped out. You can really see the mind's progression, right? From the purely sensory world of an infant to the symbolic but totally self-centered world of a toddler, then gaining logic but only for the concrete world, and then finally achieving the power of abstract reasoning that really defines adult thought. But Piaget wasn't just some abstract theorist locked in an ivory tower. His blueprint for the mind had some profound, real-world implications, and nowhere is that more true than in the field of education. Remember that core idea of the child as an active scientist? Well, that has huge implications for the classroom. If it's true that children construct their own knowledge, then having them sit passively in a chair while listening to a lecture is just not the best way for them to learn. Piaget's work really champions hands-on, discovery-based learning. It tells us that teachers should be facilitators who guide exploration, not just lecturers. And crucially, that the curriculum has to be tailored to the cognitive stage of the student. Now, like any great architectural plan, Piaget's theory has been celebrated for its sheer brilliance, but it's also been scrutinized for its limitations. So let's take a quick, balanced look at its legacy. On the one hand, his view of the child as an active learner was completely revolutionary, and you just can't deny his influence on education. But on the other hand, research that came after him has shown that he may have underestimated what kids are capable of at certain ages. Critics also point out that the stages can seem a bit too rigid and that he didn't pay much attention to the powerful roles that culture and social interaction play, which is a huge point of contrast with his contemporary, Lev Vygotsky, who argued that learning is, at its core, a social process. Today, we're diving into the pretty revolutionary ideas of Lev Vygotsky. He had this incredible argument that our minds are fundamentally shaped, not by us alone, but by the culture and the people all around us. Okay, so here's how we're going to break it down. First up, we'll tackle his big idea, the socially shaped mind. Then we'll get into probably his most famous concept, the zone of development. After that, we'll look at what he called the ultimate tool for thinking, which is language. And to wrap it all up, we'll see how his theory actually holds up today. What's its impact and what are some of the critiques. So let's jump right in. Vygotsky's central argument really does flip the script on how we tend to think about learning. He basically proposed that our cognitive development isn't this isolated journey of self-discovery. Nope. He saw it as a deeply social and collaborative process right from the very beginning. And this quote right here, it just perfectly captures the essence of his theory. Vygotsky argued that pretty much every function in a child's development shows up twice. First, it happens on a social level, between people. He called this the interpersonal plane. And only after that does it show up on the individual level, inside the child's own mind, the intrapersonal plane. Think about that. Higher cognitive functions like attention or memory, they don't just pop into existence. They actually start as relationships between people. Now, this idea really sets up a crucial contrast with his famous contemporary, Jean Piaget. You've probably heard of him. Piaget's view was that a child is kind of like a little scientist, exploring the world on their own, going through these universal stages. But Vygotsky, he had a totally different metaphor. He saw the child as an apprentice. This apprentice doesn't learn in a vacuum. They learn by doing, by participating in real, culturally meaningful activities with someone who knows more, a parent, a teacher, maybe even another kid. So you might be asking, how does this social learning actually happen? Well, Vygotsky believed that every culture gives its members what he called tools of thinking. And we're not just talking about physical tools like hammers. Note, these are psychological tools that literally shape how we think. Things like language itself, our counting systems, writing, symbols, even the strategies we use to solve problems. These are all cultural tools that we absorb and make our own. And this is a huge point. Since these tools are different from culture to culture, Vygotsky argued that how we develop cognitively isn't universal at all. It's deeply tied to our specific culture. Okay, and this idea of guided learning brings us straight to the heart of Vygotsky's entire framework. We're talking about the zone of proximal development, which is really the engine that makes all of this happen. So, the zone of proximal development, or ZPD as it's often called, is, well, it's kind of this magical space of potential. It's not about what a kid can already do, and it's definitely not about what's totally beyond their grasp. The ZPD is that perfect fertile ground for growth. It's the sweet spot where a learner is right on the edge of understanding something new and just needs a little bit of help, a little bit of social support to get over the hump. Let's actually break this down. You can think of it as 3 zones. So zone 1 is what a child can already do independently, right? Easy. They might even be bored. Zone 3 is stuff they just can't do yet, no matter how much help they get. It's too far off and they'll just get frustrated. But that middle zone, zone 2, that's the ZPD. It's what a child can do with assistance. And if you're a teacher or a parent, that is precisely where you want to be. It's the zone where real learning and development kicks into high gear. So how do you actually work inside this ZPD? Well, you use a technique called scaffolding, and the name is perfect. Just like the scaffolding on a building, it's a temporary support structure. Think about this puzzle example. A teacher isn't going to just solve the puzzle for the kid. That doesn't help. Instead, they provide hints and strategies. They might say, hey, why don't we find all the flat edge pieces first? Or, that piece looks blue. Maybe it's part of the sky. As the child starts to get it and internalizes these strategies, the teacher backs off, giving less and less support until, boom, the child can do it all by themselves. That's scaffolding, right there. All right, so we've talked about these cultural tools of thinking. But for Vygotsky, there was one master tool, the one tool to rule them all, you could say, and that was language. Vygotsky laid out this really fascinating progression for how language develops. It starts with social speech, just talking to other people. But then, somewhere between ages 3 and 7, kids start using what he called private speech. You've totally seen this. A kid is playing with blocks and is just talking to themselves out loud, narrating what they're doing. Now, Piaget kind of dismissed this as egocentric, like the kid didn't know any better. But Vygotsky saw it as something absolutely critical. He realized the child was using language to guide their own actions, to regulate their own thinking. And eventually, that out loud private speech, it goes quiet. It goes underground and becomes our silent internal thought, our inner speech. So, in Vygotsky's view, our very consciousness, our inner monologue, is literally internalized social dialogue. Wow. Okay, so we've got the core concepts down. Now let's kind of put this theory in context. How does it actually apply in the real world? And, to be fair, what are its strengths and what are its weaknesses? When it comes to education, Vygotsky's influence is just immense. It's hard to overstate. I mean, his work is the foundation for so many things we now take for granted, like cooperative learning, peer tutoring, and reciprocal teaching. His ideas tell us that the best classrooms aren't silent rows of desks. No, they're buzzing with purposeful conversation, where students and teachers are building knowledge together. There are entire educational programs, like the Tools of the Mind curriculum, that are built directly on these principles, focusing on self-regulation and learning through social interaction. But, of course, like any major theory, Vygotsky's isn't without its critics. We have to look at the other side. So its biggest strength is obviously its focus on social and cultural factors. That's huge. But on the flip side, critics point out that he's a lot less specific about developmental stages than, say, Piaget was. And key concepts like the ZPD, they make perfect sense intuitively, but they're really, really hard to actually measure in a scientific way. Plus, some argue that in his focus on the social, he might have downplayed the role that biology and simple maturation play in a child's development.
So when you boil it all down, what's the big takeaway? Vygotsky's legacy is that he completely reframed how we see the mind. Development isn't just something that unfolds from the inside out. He showed us that it's a process of apprenticeship. We become thinkers by absorbing the tools, the language, and the guidance of our culture. And this all happens through interactions inside that incredibly powerful space of potential, the zone of proximal development.
Have you ever really stopped to think about the biological engineering required to build a human being from just a single cell? It all happens in just 9 months. The whole process is this incredible, perfectly timed cascade of genetic signals and cellular changes. It's just staggering. So today we're going to explore that blueprint for life.
And that brings us to our central question. Because really, the first 8 weeks, that's the embryonic stage, that's where the entire body plan gets locked in. So how does a tiny cluster of cells know what to do? How does it get the signals to build something as ridiculously complex as a brain or a heart that beats? Well, the answer is all about this profound process of cellular communication and differentiation.
So our journey kicks off in what's called the germinal period. We're talking about the first 2 weeks here. A whole series of events unfolds, usually before a pregnancy is even on the radar. This phase is all about rapid cell division and making a crucial journey from the fallopian tube to the uterine wall.
Okay, take a look at this. This diagram shows that initial voyage perfectly. As the zygote travels down the fallopian tube, it's not just floating along, no way. It's constantly dividing, cell after cell. This trip is absolutely critical because by the time it gets to the uterus, it has to have transformed from one cell into a complex structure that's ready to implant.
Let's just walk through this timeline. Right after fertilization, the first cell division happens at about 36 hours. By day 3, you've got a merula, basically a solid ball of cells. Then, a huge change happens. It becomes a blastocyst, which means it now has a fluid-filled cavity inside. The really key part here is that by day 6, when it gets to the uterus, it's not just a clump of cells anymore. It's a specialized structure, ready for the incredibly complex process of implantation.
And this slide right here, this shows the very first critical moment of differentiation. You see, the blastocyst isn't uniform. Those outer cells, they form something called the trophoblast, which is going to become the placenta. But the inner mass of cells, that's different. That contains the pluripotent stem cells that will form the entire embryo. So right away, you see this fundamental split. One group of cells is all about support, while the other group holds the blueprint for the person.
Okay, let's move into the embryonic stage and see how this all builds. From week 2 all the way to week 8, the rate of cell differentiation just explodes. This is where that inner cell mass we just talked about starts to form the actual foundations of the body. It is, without a doubt, the most critical and delicate phase of the entire process.
This quote really drives home just how efficient embryonic development is. I mean, think about that for a second. The unbelievable complexity of the human body. From the neural networks in your brain to the chambers of your heart, it all originates from just 3 primary layers of cells. It's cellular specialization at its absolute most fundamental.
So, this table is basically the architectural blueprint. You've got the ectoderm, the outermost layer, which forms our interface with the world, the nervous system, the skin. Then there's the mesoderm, the middle layer. That gives us our structure and plumbing, muscles, bones, the circulatory system. And finally, the endoderm, the inner layer, folds and develops into all our internal linings and organs, like the digestive and respiratory tracts. This whole process, this master construction phase, it has a name, organogenesis, the genesis of organs. And because the foundational body plan is being laid down, this period is also when there's maximum vulnerability to teratogens. Those are external things that can cause developmental problems. Any disruption at this stage doesn't just create a minor flaw, it can alter the fundamental architecture of the entire organism. The stakes are incredibly high.
And the speed of it all is just breathtaking. On day 21, the first signs of eyes start to show up. Just 3 days later, the heart cells get to work. By week 4, you can see arm and leg buds, and the heart chambers are taking shape. And by 8 weeks, the face and internal organs are forming. And get this, at this point, the embryo is just a little over an inch long. Now, while all of this construction is going on, there's a whole other sophisticated life support system developing right alongside it. And what's so fascinating to me is that these systems, the amnion, the umbilical cord, the placenta, they all develop from the original fertilized egg. They're not part of the mother's body. They are created by the embryo for the embryo.
Let's just look at this toolkit for a second. The amnion? It creates this perfect little sterile, temperature-controlled, shock-proof world to float in. The umbilical cord is the vital lifeline. And the placenta? Well, the placenta is a marvel of biological engineering. It's this incredibly smart interface that lets nutrients and oxygen in and waste out, all without the mother's and baby's blood ever actually mixing, which, by the way, is crucial for protecting the embryo.
So, after this first 2 months, the blueprint is pretty much complete. Now we enter the fetal period, and this lasts right up until birth. This phase is all about growth, maturation, and refinement. The organ systems are there. Now they just need to get bigger and become fully functional.
So by the end of that first trimester, around 3 months, the fetus is about 3 inches long and weighs roughly 3 ounces. But it's not just about size. The key development here is function. It's active now, making coordinated movements, and in a major developmental milestone, the external genitals are now differentiated and identifiable.
From here, the growth just accelerates dramatically. By the end of month 5, we're talking about a fetus that's close to a pound and about a foot long. But even more than that, this is when protective coatings cover the skin and the movements become strong enough for the mother to feel them. It's a huge moment.
Now, by the end of the 6th month, the fetus has usually reached the age of viability. And while it's still getting bigger, the really critical developments are happening inside. The lungs are developing surfactant, which is essential for breathing air after birth, and the neural circuits are maturing. You can even see reflexes like grasping. This is really the turning point from just growing to actively preparing for life on the outside.
So, with all that in mind, let's pull back and put these stages together into one cohesive timeline. Let's trace the whole journey, from that single cell all the way to a near-term fetus.
When you look at it this way, it really all boils down to these 3 distinct sequential stages. You have the germinal period, which is all about establishing the pregnancy. Then the embryonic period is for laying down that architectural blueprint. And finally, the fetal period is all about building on that blueprint, letting everything grow and mature.
How on earth does a single cell, a totipotent cell, manage to build something as complex as a human being in just 40 weeks? That is exactly what we're going to explore. All right, here's how we're going to break it down. Think of it like a 3-act play. First, we've got trimester 1, which is all about building the foundation. Then trimester 2, where the focus shifts to growth and movement. And finally, trimester 3, the period of final maturation. To wrap it all up, we'll take a step back and look at the overall developmental blueprint itself.
So let's start with Act 1, the first trimester. This is the period of organogenesis. It's an absolutely critical phase where the fundamental body plan gets laid out and all the major organ systems get started. Seriously, everything that happens here sets the stage for all future development.
And the whole story begins right here with the zygote. This is that single totipotent cell, which means it contains the complete genetic blueprint for an entire person. The first thing it does is start dividing. These rapid cleavages that don't actually make the whole thing bigger, but just partition the cell, getting everything ready for the complex differentiation that's about to kick off.
By just 4 weeks, and get this, it's less than 1/10 of an inch long, development is happening at a mind-boggling pace. The process of gastrulation has already established the 3 primary germ layers that will give rise to literally all tissues. The precursor to the brain and spinal cord is forming, and a primitive heart has already started to beat. It's an incredibly vulnerable period of intense architectural work. But things move so fast, development just proceeds at this breakneck speed. And by the time we hit the 8-week mark, the developing life takes on a whole new, more recognizable form. And this brings us to the embryonic period, which lasts right up through week 8. Now the focus shifts from just cell division to differentiation and morphogenesis, actually shaping the body. This is the critical window where all the major structures, internal and external, take shape, which also makes the embryo incredibly susceptible to teratogens, which are agents that can cause developmental problems. And in just those 4 short weeks, it has grown 10-fold. At 8 weeks, the embryo was about 1 inch long. I know, it still sounds tiny, but the level of complexity inside and out has just increased exponentially.
By 8 weeks, the complexity is just remarkable. You've got facial features becoming distinct. Those little limb buds have now developed into arms and legs that can actually move on their own. And critically, the cardiac system is now developed enough that you can detect a heartbeat on an ultrasound, a really definitive sign of viability at this early stage.
Now, at the end of that 8th week, we have a major transition. The embryonic period ends and the fetal period begins. So with all the primary organ systems now in place, the focus shifts dramatically. It's no longer about formation, it's about growth and functional maturation. The architectural blueprint is basically complete. The rest of the pregnancy is all about building it out and refining everything.
By the end of the first trimester, around 12 weeks, the fetus is already showing some surprising refinement. It can make coordinated movements and even has primitive reflexes like sucking. And what's amazing is that the unique ridges that form our fingerprints have already developed. At this point, you can also distinguish the sex.
And that brings us to Act 2, the second trimester. We're talking growth and movement. Now that the foundational blueprint is set, this whole period is about rapid expansion and developing sensory capabilities. The fetus actually starts to interact with its environment.
Between 16 and 20 weeks, those movements become way more coordinated and, importantly, perceptible. The fetus can suck its thumb, it can get hiccups, and for the mother, this period often holds a really profound moment. It's when she usually starts to feel that movement for the first time, what's known as quickening. It's a huge psychological and physiological milestone. This brings us to a really critical threshold, the age of viability. Right around 24 weeks, survival outside the womb becomes a possibility. But, and this is a big but, it's only with intensive medical intervention. The main limiting factor is the lungs. They've started producing surfactant, which is crucial for keeping the air sacs from collapsing, but the whole system is still extremely immature. And this comparison really shows you just how rapid the maturation is during the second trimester. In just 8 weeks, the fetus more than doubles in length. Its skin goes from transparent to being protected by this waxy coating called vernix. And neurologically, a huge step. The eyes can now open and respond to light, which is a major leap in sensory development. Okay, and that leads us to our final act, trimester 3, final maturation. This is the home stretch. This period is all about rapid weight gain and making those final preparations for life on the outside. As you can see from this chart, the third trimester is just defined by this exponential weight gain. Most of this new mass is body fat. Now, this isn't just about getting bigger. That fat is a critical energy reserve and provides thermal insulation, which is going to be absolutely essential for surviving that transition from the stable uterine environment to the outside world. This is also a period of intense practice. I mean, the fetus becomes super active, performing these rhythmic breathing movements to strengthen its diaphragm and chest muscles. It develops clear sleep-wake cycles and starts responding to external sounds and light. It's basically rehearsing for life. In these final weeks, all the finishing touches are put in place. The skin gets smooth as that fat is added. And, most importantly, there's a massive transfer of maternal antibodies across the placenta. This gives the newborn what's called passive immunity, providing vital protection from germs during those first few months of life, while its own immune system is still getting up to speed. So, after that whole journey through the trimesters, let's just step back for a second and look at the big picture, the developmental blueprint, to really understand the overall pattern of this incredible process. You know, you can really see this whole transformation as a sequence of distinct stages, and each one has its own unique biological job. The zygote is for division, the embryo for formation, the fetus for maturation, and finally, the newborn, ready for life. This entire journey reveals a few key biological principles. First, development is cephalocaudal, meaning it literally proceeds from head to tail. It's also proximodistal, developing from the core outwards. Viability, as we saw, really hinges on the lungs being mature enough around 24 weeks. And those final weeks are all about acquiring the resources, like antibodies and fat, that are needed to survive on the outside. So, from one single cell to a fully formed human, this 40-week journey is just this incredible story of progressive, intricate, and perfectly timed transformation. It is a process of absolutely astonishing complexity and precision.